All right, Algebra 2 review for lessons 1 through 20. It also happens to be our quarterfinal. Everybody's got the document pulled up in front of them, so we're just going to work it out on blank sheets of paper. We've gone through, we've made a list of which questions students want covered first, and so we're actually going to start with question number 1. Question number 1 says a research doing a study notices an inverse relationship between the number of bears and the number of beehives in a certain part of the woods. This varies depending upon what time of year it is. His observations are as follows. What I'm actually going to start with, though, is I want to start with the inverse variation equation. Do we know what that equation is? Y equals k over x. Okay? Now, the next thing I want to do with this equation is I want to know how I can rewrite the equation to solve for my constant. How do I solve for k? Y times x equals k, correct? All right. Our chart, okay, which is bears to beehives, tells me I've got 4, 12, 6, 8, 8, 6, 12, 4. All right. So hopefully we see a couple of things here. Hopefully we know which one of these is my independent variable and which one is my dependent variable. Now they're really nice to you in that they don't really switch it up. What is my independent variable here? Is it bears or beehives? Bears, right? Because the number of bears affects the number of beehives. The number of beehives does not affect the number of bears. Why? Because bears are eating beehives, right? Beehives are not, somehow affecting the population of the bears, except in terms of where it deals with food. So, if I want to know what my constant is, what am I going to do with the number of bears to the corresponding number of beehives? Multiply, right? Y times x equals k. All right? So, what's 4 times 12? 48. Okay, what's 6 times 8? 48. What's 8 times 6? 48. What's 12 times 4? So do we have a constant? Yes, our constant is 48. Okay, so k equals 48. All right, so let's look at question A. If x represents the number of bears, okay, y represents the number of beehives, find the inverse variation function from the table above. All right, so the first thing that we had to do was find our constant, correct? Now we're going to plug our constant back into our original equation. All right, so what is my equation now? No, my equation is not 48. Y equals 48 over x. That is right. Okay, so we have to find our constant 1 and then plug it into our inverse variation equation, because what this tells me is that if I know how many beehives I have, I can tell you how many bears there are, right? If I know how many bears there are, I can tell you how many beehives there are, right? Because by getting to 48, it allows me to solve based upon just one variable, okay? All right, B. Later on, the researcher counts 24 bears. How many beehives are there? Okay, so let's pull this down. All right, now I'm going to use my answer from A to solve for B. Okay, what am I going to do? They tell Y equals 48 over 24, because x represents my bears. I know I've got 24 bears. What's 48 divided by 24? Y equals 2, and y equals number of beehives, so I have 2 beehives. Okay, just need the 2 part of that there. Does that make sense? Hopefully, we understand the process involved there. Okay, so you're going to have to show me how you got 48. Okay, because if we see this question on a test, you might remember 48. I need you to tell me, show me, give me the work. How did I get there? Okay. All right, the next question up is number 3. Number 3. Suppose the average teenager spends about 57 hours per month in a car. How many minutes per day is this? Okay, so we have a rate. 57, what? Hours over what? Over 1 what? Month. I need to convert hours per month into what? Minutes per day. Okay, so what do I want to convert? Do I want to convert months to days or hours to minutes? Hours to minutes is what? Months to days? Okay, all right. So notice, and they tell you that this is kind of what we need to do, because notice the last part, what's in parentheses at the bottom of that question? Assume a 30-day month. The reason that they say that is because not all months have 30 days. All right, so what am I going to put up top if I'm converting from months to days? What unit? Ooh, so we don't understand. We got to understand conversions and how they work. If I'm trying to cancel out months to get days, what's going to go on top? Months. Months. There we go. And I want days, right? Okay. What number gets the one? Or sorry, what unit gets the one? Months, and we have 30 days, right? Now that's done in terms of days, right? Now we have to convert hours to what? Okay, so where do hours go? Top or bottom? Bottom, because I want them to cancel out. All right, we want minutes up top. Okay, where does the 1 go? Bottom, because hours are bigger. How many minutes in an hour? 60. Okay, so this is going to give me minutes per 1 day, right? All right, so we might actually, I'm going to go ahead and get that 1 out. We need 57 times 1 times 60. What's that number come out to? We're going to leave this unsimplified to begin with, so don't jump straight to the answer. 57 times 1 times 60. 3,420 minutes, and that's over 30 days, right? All right, but we want minutes per 1 day, right? Okay, so what am I going to do with 3,420 over 30? Divide, right? So we get minutes per 1 day. Okay, what is that? 140? 114, sorry. My hearing must be just really awful. It's been this way all day. 114 minutes per day. Let's check our answer key and make sure that that, in fact, is the answer. 3. Wow, I got pages and pages of answers. 114 minutes per day. Okay, very good. All right. Do we understand how to show our work? Great. All right, question number 2. Question number 2. A subway pass costs $20, and $1.50 is deducted from the balance on the pass every time you use it. We want to write and graph an equation to represent this situation and then graph it. All right, so if we're going to graph this equation, it's probably going to be a y equals, right? What amount of money am I starting with? 20. Every time I use it, am I adding or subtracting from that $20? Subtracting. What is the rate on that subtraction? 1.5. 1.5x. So that's my equation. Okay, does that make sense? Now, what might I want to do to rewrite that equation so that I could graph it? Plus 20. Okay? Now, I'm not going to go necessarily to great lengths to do a bunch of this, but my y-intercept should be at 20, right? should be able to show, maybe 5, 10, 15, 20 or something to that effect. My slope is negative, so I'm actually, negative 1.5 could be rewritten to better how to help me get my slope calculated correctly. What might I want to do with negative 1.5? Put it in a fraction form. What's the fraction? Negative 3 over 2x plus 20. So I'm going down 3 over 2, down 3 over 2, down 3 over 2, right? So I should be getting an equation that is roughly going to look like that. All right. I'll give you graph paper if you were to see this question. All right, does that make sense? And have you show me and graph that correctly. Okay? So my guess is that if you were to see this question, this would be the equation that they're going to look for. Okay? All right. Let's see, number 7. Number 7. All right, identify the slope and the y-intercept of the line with the equation y equals negative 3/5 x minus 3. Okay? The slope. What is the slope? Negative 3/5. Did you say yes or x? Okay, good. We don't include the x, right? Don't include the x. Okay, y-intercept. What is the y-intercept? Negative 3. Okay, do we need help graphing this? No? Okay. We're going to start at negative 3. We're going to go down 3 over 5, down 3 over 5. But because we're already starting with a negative y-intercept and we're going down, what might I need to do with this graph to get a complete line? Might I need to go up 3, back 5 in order to get a couple more points on the graph? Yes. Okay. All right. Number 5. Okay. We have parentheses 6x cubed. Okay. Number one thing to do here off the beginning is what? Can I combine like terms yet? No. What do I have to do first? Distribute the negative. Thank you. Okay. Just to the x cubed, right? To all 3. Okay. All right. So we have 6x cubed plus 4x. What? Minus x cubed minus 3x plus 15. Okay? Combine like terms. Okay, so we said 6x cubed minus x cubed, which is what? Good. 5x cubed. 4x minus 3x is? Okay. Plus positive, right? Positive x. And what? Add 15. Okay? It just says subtract. It doesn't say that we need to, break this down any further. So if somebody wants to check the answer key on number 5 and make sure that's as far as they're looking for us to go. Is it? Okay, that's our answer. Okay. All right, after 5, you guys picked number 9. Number 9. Okay. Good question because this is something that people are struggling with. Number 9, determine if the linear system below is consistent and independent, consistent and dependent, or inconsistent. If the system is consistent, give the solution. They already give you half the answer, right? Right? They told me if the system is consistent, give the solution. The fact that there is a solution, right? Can you tell that there's a solution? Yeah, because they cross. So we know that it's consistent because the two lines cross, right? So the question is it independent or dependent? Do you know? It's independent. The reason it's independent is because what happens to one line does not affect what happens to the other line, right? Okay, they are independent of one another. Okay? Does that make sense? Now, we do need the solution. Do you guys know what the solution is? The solution is the coordinate location where they cross. 0, because my x value is 0, and my y value is 6. All right? Are we correct according to the answer key? Question number 9. Consistent, independent, 0, 6. Okay? So if it has a solution, it will be consistent and independent. Okay? So you need to go and look. Let's see. Question number 9 comes from lesson 15. If you struggle to know when something is consistent, when something is independent, inconsistent, dependent, go back and look at lesson 15. Spend some time with those charts. And in fact, we've seen like 3 or 4 different charts that all give that same information, have we not? Right? And those have been in my notes several times. All right, so go back and look at those, because sure as the world, we're going to see something like that on the test. All right, number 10. Okay, number 10. Solve the system by graphing. Okay, it says 7y plus 3x equals 16. Negative 2y plus 3x equals 7. All right, so if I'm going to graph this, what do I need to do? You need to get y by itself. Okay, we can do it that way. There is another way, just so that you're aware. We could solve by using x and y intercepts, couldn't we? Do you guys remember using x and y intercepts at all? No. Well, if you don't want to do that, then we'll go with the first suggestion, which is get y by itself in both equations. By getting y by itself in both equations, my equations are going to be in slope-intercept form. Plot the y-intercept, plot the slope, and then look for where they cross, correct? Okay. All right. So with equation, the top equation here, what's the first thing you want to do? 7y. Okay, you're going to subtract 3x, so we get negative 3x. Oh, gosh, that hurt. All right, minus 3x plus 16. Divide by 7. All right, so we're getting y equals negative 3 over 7x plus 16 sevenths. Right? All right, and then in our other one, right, what are we going to do there? All right, so we got negative 2y equals negative 3x plus 7. Divided by negative 2. Okay. All right, we got to stop there for today, unfortunately. Okay. I'll try to finish this up. You guys obviously do still have the answer keys in the back, so you can look at that there too. Okay.